precious metals. Your house, all August. Welcome to Treasure at Home with Young Tassie Scientist, Liam.
Hello everyone, welcome to episode 3 of Treasure at Home. I thought that for this week we would pay tribute to a couple of elements that don't actually fall under the category of precious metals, but are precious nevertheless. And those are the organic elements, carbon, nitrogen, oxygen, and hydrogen. And of course, where is the best place for you to find these? Well, I'm going to show you some excellent examples that you can find this week in your own house. On today's episode, let's find out why chilies make food hot and spicy, and why sometimes when you're eating mint-flavoured foods, it can leave a cold feeling in your mouth. Also as a bonus, we'll find out why the biggest things inside of coffee and chocolate are separated by a single carbon. As always, it's extremely easy to play along at home. There's only one thing you need. It's probably already in your house. Let me show you what that is. It's the kitchen. Everything you need today you can find in your average kitchen, so let's get started. So Liam, take us away. What's the deal with chilies being hot and spicy? So some of the best places to find these precious organic elements, carbon, hydrogen, nitrogen and oxygen, is pretty much all in our foods, and nature does a very good job of putting these all together. Take this for example. You might have seen one of these before. This is just a common red chili, but there is a chemical compound that contains almost all 4 of those elements, carbon, hydrogen, nitrogen and oxygen, that gives foods with chili in it their spicy taste. And we'll take a look at this right now. So here we are, treasure hunters. This is capsaicin, the molecule that makes you cry your eyes out when you're having hot and spicy food. As you can see, it has carbon, nitrogen, oxygen and hydrogen. So while chili will make some of your foods hot and spicy, there are other things which might give a cooling sensation in your mouth. If you've ever brushed your teeth before, you might have had spearmint toothpaste. Here is a mint leaf here. Inside of this mint leaf, there is a compound called menthol, which we'll take a look at now. Here is a structure of menthol here, and as you can see, it's a lot smaller and a lot more simpler than capsaicin. It doesn't even have a nitrogen atom in it, but it does have carbon, oxygen, and hydrogen. This is what gives that cool sensation in your mouth. Menthol is also extremely useful in our day-to-day lives. But how do we get our hands on it? If we need to be able to use it, where are we going to get it from? We need to extract it. So this is quite a common practice and a very easy way to do some chemistry at home. You might have made jams before, you might have made all sorts of stuff in the kitchen, but a very common practice is taking stuff like mint leaves, or our next guest from the kitchen, mashing them up and getting a liquid out on the other side, which contains all of the chemicals that were originally inside the leaves or fruits or berries of what you've picked. For example, in some kind of factory, there would be a machine which takes just hundreds and hundreds of thousands of these mint leaves and produces this peppermint extract. So when you're making like choc mint cookies or mint flavored ice cream or something like that, you add drops of this in it because it's a more concentrated version of that compound from mint. Speaking of cooking with mint, there's not just one molecule in mint that we are interested in if we're using it in the kitchen. We've already mentioned menthol here on the left, which gives that cool flavour in your mouth. But here on the right, you'll also see this molecule called carvone. And carvone is what gives mint leaves their taste, like the taste of mint and the smell of mint. So if you crush the leaves up in your hands and the smell comes over your nose, you are smelling carvone. These are the 2 molecules that we're after when we are interested in cooking with mint. So to finish off today, I thought we would do something a little bit more in line with what my research is all about. When I'm in my research lab, and there are other videos where I talk about it, I'm always looking to add a single atom of carbon to metallic molecules. So we're not looking at metallic molecules today, but I can show you some interesting things that happen by adding a single carbon. I reckon you guys have probably seen this stuff before. One of my favourite things, and certainly something I treat myself to often, is chocolate. And what gives chocolate its colour, its flavour, all these different things that we've been talking about today? It's a molecule called theobromine. And theobromine is something that comes through in nature in cocoa. So you use cocoa to make chocolate. That's how you get theobromine into chocolate. This here is an average block of chocolate. It's milk chocolate, which means that it would have an average amount of theobromine in it. Just think about colours of chocolate as well. So we've got our milk chocolate there. If we then go to a dark chocolate, like this one, that would have a lot more theobromine in it because there is more cocoa. And then, lastly, if we go the other way and we have white chocolate. White chocolate, which has very, very little cocoa in it, would have very little theobromine inside. So it just goes to show that by changing the amount of one molecule, theobromine, you can get very different things inside of your kitchen. But that's by changing a different amount. So we've got this molecule, theobromine, in chocolate. But there's a funny thing that happens with that molecule if you add a single carbon group to it. By that stage, I probably shouldn't hold up this anymore, but much rather this. This is coffee. And the reason that a lot of adults drink coffee is because of a molecule called caffeine. It's a molecule that makes you feel less tired, and people often have it while they're working through the day. But as I can show you on screen, these two molecules are very closely related, all by a single carbon. So here we have chocolate on the left and coffee on the right, theobromine versus caffeine. And as I said, that these molecules are very closely related, and I think you can see that quite clearly. If we look at the left-hand side of either of these molecules, you've got like a 5-membered ring with 2 nitrogens in it, and that is exactly the same for both molecules. But the interesting part is in the 6-membered hexagon part on the right-hand side of these molecules. You'll see that they've both got a nitrogen and they've both got 2 oxygens, and then there's the nitrogen in blue. That's where the different chemistry is. Theobromine has a nitrogen-hydrogen bond, but caffeine has a nitrogen-carbon bond. So as you can see here, by adding a single carbon to theobromine, we get caffeine out of chocolate and into coffee. That's the difference that a single carbon can make. So treasure hunters, that'll be it for another episode of Treasure at Home. I hope you've had fun wandering around the kitchen and getting stuck into those cupboards looking for chili, peppermint, coffee and chocolate. In fact, I'm just going to sit here and treat myself to some chocolate right now. If you like these videos, we've got plenty of other episodes up for National Science Week, and we have not just Treasure at Home videos, but of course the fantastic one-of-a-kind Young Tassie Scientists. Please check out the YouTube channel and our website to go and support the rest of these fantastic young scientists.